Am I audible, ma'am?
Hello, sir. Sir,
Yeah, yes, ma'am. Audible.
there are no students is done. Okay, they have started to join. We will start the class at 3 p.m., sir.
Yeah, okay.
Okay.
Shall we start, ma'am? Hello?
1 second, sir.
Yeah, okay.
Yeah. Hello, everyone. Okay. Did everyone can see my screen? Okay. Is my board and what I am written is clear to all? Okay. Yes. Shall we start? Yes, of course. Okay. So in last week also we are solving some problems in matrices, right? Right. Today we are also solving some problems in matrix, right? Right. So our first problem is show that the given matrix is equals 2 multiplied by a plus b plus c the whole square. Okay? Okay. Shall we start to solve? Yes. Okay, so I am writing solution. Right? Right. So I'm going to take the LHS. So LHS equals. So what is LHS? A plus B plus 2C A B C B plus C plus 2A B and C A C plus A plus 2B. So this is the given matrix, right? Right. What I am going to do now is I am going to replace the column 1, right? By so I am going to replace column 1 by adding all the 3 columns. So C1 is going to become C1 plus C2 plus C3. Right? Right. Shall we? Yes. Okay. So what is C1 here? Right? What is C1 here? Ah. A plus B plus 2C, C, C, right? We are going to replace C1 by C1 plus C2 plus C3. See here, we are going to replace this. So A plus B plus 2C, so C2A plus C3B, right? Right. So similarly, A and B remains the same. I mean C2 and C3 remains the same. Here, C is C1 plus C2, B plus C plus 2A plus C3, so plus B. So what we have remaining? B plus C2A and B. Okay? Okay, likewise in C1 lost element. C plus A plus C plus A plus 2B and here C plus A plus 2B. Clear? Clear. So now we are going to simplify this. So which is equals C. Here A. So it will becomes 2A and here B. So plus 2B and here we have 2C. So plus 2C. Clear? Clear. And remaining two elements remains the same. A and B. Right? Right. When we check with row 2, here's 2A. So 2A. And here on B. So plus 2B plus here on C. So plus 2C. Our remaining two elements remain the same. Okay? Okay. So here 2A plus A 2A and here 2B plus here on C. So 2C, here A, here C plus A plus 2B. Right? Right. Clear? Clear. See, in all the elements we have 2. So I'm going to take that out. Right? Right. See, I'm writing this here, right? Right. So it will becomes 2 multiplied by A plus B plus C and A and B. Here also 2 multiplied by a plus b plus c, and here b plus c plus 2a and b. Okay, clear? Clear. Now what I am going to do is, I am going to take this term 2 multiplied by a plus b plus c in c1 as common, right? Right. So it will become 2 multiplied by a plus b plus c in on, right? We taken all the 2 multiplied by a plus b plus c as common from column on, right? Right. What is the elements we have as remaining here? A and B. Here B plus C plus 2A. Here B. Here A. So C plus A plus 2B. Clear? Clear. So what is the next step? Okay. So my next step is I am going to replace second and third rows in the matrix. So I am going to replace row 2 by row 2 minus row 1. Clear? Clear. Similarly, I am going to replace row 3 by row 3 minus row 1. Clear? So what you will get? So we have to multiply by a plus b plus c as common, and row 1 we never tested, so it remains the same. So row 2. So row 2 is row 2 minus row 1. So what is the first element? 1. So 1 minus 1 will be 0. Here in the second place, row 2 minus row 1. Here b plus c plus 2a, here is 1a. So 2a minus a, we will have a. So it will be b plus c plus a. Say here it is. Okay. So see, here it is R2 minus R1. B minus B, it's 0. Okay? Okay. So see R3. R3 will also going to change like R2. It is also like R3 minus R1. So R3 is 1. R1 is also 1. 1 minus 1 is 0. Clear? Here it is A. A minus A is 0. So here we have C plus A plus 2B. Minus B. 2B minus B. B. Super. So we will have C plus A plus B. Clear? Clear. Now I am going to take determinant, right? So here it is determinant. Now I am going to take in column wise. So it will become, okay, I will read it. 2 multiplied by A plus B plus C, right? See, we have it here. It will become, so I am going to take this one. So 1 multiplied by 1 multiplied by, like, now we have to multiply these two elements. So what we have, A plus B plus C. See here, A plus B plus C and A plus B plus C. So I can write it as A plus B plus C the whole square. When we multiply this, 0 into 0 is 0. Right? Right. For the first column. So see the second column. It is 0. So 0 and multiplied by anything is 0. So see third, third element in the first column is also 0. So it will become 0. So what we will have? We will have 2 multiplied by A plus B plus C. And what is the result of this? Again A plus B plus C the whole square, right? Right. When we do this, it will becomes, we already have A plus B plus C. Here also A plus B plus C the whole square. So it will becomes A plus B plus C the whole cube. Clear? What we have to prove? We have to prove this term is equals 2 multiplied by A plus B plus C the whole cube, right? Right. So we proved this. So we can finally write hence proved. Clear? Clear. So I will give you a half minute so you can copy this and we will move to the next sum. So if you guys have any doubt in the sum, kindly put your doubt in the chat box, right? So that I can make you clear with this sum. If no means we will move to the next sum. Yeah. I hope you all are clear with this sum. Now we are moving to the second sum. Okay. Okay, this is what the next sum we are going to solve, right? Right. So we are provided with a matrix. They said that the matrix square is equal to the another matrix, and which is again equals to a cube plus b cube plus c cube minus 3ab the whole square. Okay. Okay. So shall we start to solve? Okay, super. So solution. I'm going to take this part first, right? Right. So it will be A, B, C, B, C, A, and C, A, B. I'm just going to take this matrix first. I'm simply going to do a row wise determinant. I'm going to do the row wise determinant. So it will becomes A multiplied by, so while taking A, we have to leave this row and this column. So we have to take this alone. So it will be BC minus this one will be A squared, right? Right. And minus B multiplied by, okay. So now I am taking this element, so it will becomes minus B, so we will leave this one. So it will becomes B squared minus AC and plus, while taking C, we have to keep this shape and we will have this elements only. So it will be BA minus C squared, right? Right. So now I'm going to take this A within this. So it will be ABC minus A cube minus B cube minus into minus plus. So ABC and plus ABC minus C cube. Okay. So I'm going to write like this: minus A cube minus B cube minus C cube. Here on ABC, here on ABC, here on ABC. So here we can write it as 3ABC, right? Right. See the question we have, all the A cube, B cube, C cube are in positive and 3AB is in negative. So I am going to take the negative one as common from all the elements. So it will become A cube plus B cube plus c cube minus 3abc. See what we have to prove. So we have to prove square of this determinant is equal to this one, right? Right. So I am squaring this, taking square on both sides. Squaring on both sides. Right? Okay. So if we square this, we will get ABC, BCA and CAB the whole square, which is equals. What is the final element on the right hand side? So minus 1 multiplied by a cube plus b cube plus c cube minus 3abc the whole square. Right? So we will get ABC, BCA and CAB the whole square, which is equals. So while squaring the minus 1 we will get plus 1. Right? Right. So I am going to keep the squaring on this side as it is. So it will becomes a cube plus b cube plus c cube minus 3abc the whole square. Clear? Clear. See the question. We proved this one is equal to this one. Clear? Clear. This is the first step of the sum. So I am going to name it as equation number 1. Okay? Clear. So what we did here, we simply take this matrix and we will determine it with row 1. Do the determinant with row 1 and we finally get an answer. And what is the question? The question is matrix square, right? So we simply take squaring on both sides. So it will becomes this determinant matrix squared, which is equals to the this term, right? This is what provided in a question. So we have to prove this is also equal to this, right? Right. We will do it in the next part. This is the first part. I will give you 1 more minute so that you can copy this and we will move to the next step. Okay. I hope you all copied this one. Shall we move to the next step? Yes. Okay. The next step is I'm simply going to take this one, right? Right. Okay. So I'm going simply taking A, B, C and B, C, A, C, A, B. The whole square, right? Right. So if it is A squared means what we will write? How we will expand? We will expand it as A multiplied by A. Right? Right. Now I am also going to do the same thing. Right? Right. I am going to write A, B, C, B, C, A, C, A, B multiplied by A, B, C, B, C, A and C, A, B. Clear? Okay, super. So now I am going to do a simple change. So in the second determinant alone, right? Right. So what I am going to do is a simple switch over of R2 and R3 in a second determinant alone. So it will becomes A, B, C, B, C, A and C, A, B. First determinant remains the same. But while in determinant 2 we are replacing R2 by R3 and R3 by R2. We are just interchanging the rows. We are interchanging R2 and R3, right? While interchanging, we have to add a minus 1 minus symbol in the matrix, right? Right. See, it is also in multiplication, right? Right. This matrix multiplied by this minus 1, right? Right. So we are interchanging these rows, so it will become A, B, C, C, A, B and B, C, A. Clear? Clear. Now what I am going to do is, I am going to take this minus 1 inside this matrix. 2 or 1, right? Right. So it will become, so be clear with the first matrix, it remains the same as it is. Clear? Clear. We are doing all the changes in second matrix only. We interchange the R2 and R3. While interchanging, we will have minus 1. I am going to take this minus 2 R1. So it will becomes minus A, minus B and minus C. And C, A, B, B, C, A. So now what I am going to do is, I am just going to do a simple matrix multiplication, right? Right. So this row will be multiplied by this row. What we will get? Minus A squared plus BC plus BC. Right? Right. While doing this, minus, while doing this, see, AB minus AB plus AB plus C squared. Here in last term, minus AC plus B squared and plus AC. So I'll doing with the second row and this one. So minus AB plus C squared plus AB. And with now row 2 with column 2. Minus B squared plus AC plus AC. Here minus BC and plus BC and plus A squared. Right? Right. Plus A squared. So now we are going to do with this one in first column. So minus AC plus AC and plus B squared minus BC plus A squared plus BC and minus C squared plus AB and plus AB. Clear? Clear. Minus C squared plus AB and plus AB. So see, now we can simplify this, right? Right. So we can write. So first term we have BC, BC. So 2BC. What we have here is, okay, I will write it now. I will give you 1 minute so you can copy this and we will move to the next step. Right? Right. Okay, I hope you copied this one, so I am rubbing this. Clear? Clear. So here BC plus BC 2BC minus A squared. Here minus AB plus AB will get cancelled. What we have here? C squared. Okay. Once again, before that we can write what we started to solve. We started to solve A, B, C, B, C, A, C, A, B the whole square. This is what we started to solve and this is the final result of this. First term BC minus 2BC minus A squared and in second term minus AB plus AB get cancelled. C squared. Here minus AC plus AC get cancelled. B squared. C minus AB plus AB get cancelled. What we have? C squared. So here AC. So 2AC minus B squared. Here B minus BC plus BC will get cancelled. What we have? A squared minus AC plus AC get cancelled. What we have? B squared minus BC plus BC get cancelled. What we have? A squared. See here AB. So 2AB. What we have? Minus C squared. Clear? Clear. So I am going to name this equation as equation 2. Clear? We are going to name it as equation 2. So already we solved an equation, right? Equation 1. What is the equation 1? So equation 1 is ABC the whole square, which is equals A cube plus B cube plus C cube minus 3ABC the whole square. This is equation 1. We solved it in a 2 minutes before, right? Before getting 2, we get a equation 1, right? This is the equation 1. Now, comparing equation 1 and 2, I can write from equation 1 and 2. See? Right. See here, both the LHS are same. So we can say RHS is also same. So we can write A B C B C A C A B. Okay, it's the whole square equals 2BC minus A squared C squared B squared and C squared 2AC minus B squared A squared and B squared A squared 2AB minus C squared, which is equals A cube plus B cube plus C cube minus 3ABC the whole square. Right? Right. What we did? Initially, we take the determinant alone and we find the determinant by solving column 1, right? Right. And we squared it. That's what we get the equation number 1. So, equation 2, we expand the given matrix and interchange the columns interchange the rows R2 and R3 in second matrix alone, and we take the subtraction to the row 1, right? And we simply multiplied it. By the way, we get second equation. Finally, by comparing these two equations, what we get? We finally get this equation, the three equations, right? Right. So now see what we are going to solve. What we have to show. We have to show is this term. So see what we get. So finally we can write hence proved. Hence proved. Okay? Okay. So I will give you 1 minute so that you can copy this and we will move to the next sum. If you have any doubt, means kindly put those doubts in the chat box so we will discuss at this moment, right? Right. Okay. Okay, I hope you all clear with the sum. Shall I rub it? Yes. Okay? Okay.
Ma'am, you are in mute, ma'am.
Yeah, I'm just simply writing the questions.
Okay.
So now we are provided with the three linear equations and we have to solve this using Karna's rule. Okay. So see, we are provided with the three linear equations and we have three variables, right? X, Y and Z. We have to find what is X and Y and Z, right? Right. So before we can solve, okay, what is Karna's rule? It is AX equals B. See? Okay. So, okay. Clear? We have three variables, right? What are they? X and Y and Z. We are going to find what is X and Y and Z. Okay? And we are provided with three linear equations. And they also said you have to do it with Karna's rule, right? Right. For that, I am going to explain you what is Karna's rule first, right? Right. So we are going to replace these elements, right? This linear equations as matrices, so that we can easily find the answers, right? Right. To that, for that I am writing a formula AX equals B. Okay. Okay. So now what I'm going to do is I'm going to make three matrices. So I'm going to name my first matrix as A. Okay. Okay. So matrix is going to have only numbers, right? Right. For the first matrix A, I am going to take the left hand side of the three equations, right? Right. I am going to write only the coefficients of the variables. I am not going to take the whether x or y or z. We are not going to take that. We are only going to take the coefficients, right? Right. So here I am going to take the first element. What is the coefficients? 3. Sorry, it's 4, right? Yes. So 4 and 5. Clear? Clear. Similarly, for row 2, I am going to take the equation 2. So it will be 2 minus 1, 8. So row 3, we are going to take 5 minus 2 and 7. So this is matrix A. So matrix X is so simply the variables X, Y and Z. So and matrix B. The matrix B is 8. What we have in the right hand side? 18, 13 and 20. Clear? Clear. So what is corner's rule? Okay. The corner's rule is x equals del 1 by del and y equals del 2 by del and z equals del 3 by del. So this is Karnal's rule. See, we can actually know what is del. So del is simply a determinant of a matrix. What is del 1, del 2, del 3? They are simple. So here we have a matrix A, right? Right. So if I am going to find del 1 means we are going to replace the first column by the elements of B. Clear? If you are going to find del 2 means we are going to replace the second row by B. If we are going to find D3 means we are going to replace third column by B. See, whatever may be the del numbers, we are going to replace that particular column with the elements of B, so that we can get del 1 and del 2 and del 3. And to find del, we are going to find x or y or z, we are going to divide del 1 and del 2, del 3 by del. Clear? Clear. So what is corner rule? Cramer's rule: x equals del 1 by del, y equals del 2 by del, z equals del 3 by del. That is Corner's rule. So what we have? We have a matrix A and B and what? And we take the variables we are going to find as another matrix X. Right? To solve this, we are going to take this matrix, A matrix alone, right? Right. So initially we are going to find del. C equals, okay, C equals 3, 4, 5. So del equals determinant, right? For taking determinant, we are going to take the A matrix. We are going to take determinant for matrix A. Clear? Clear. Shall we solve? Yes. So I am going to take the determinant using row 1. So it will be 3 multiplied by minus 7. Minus of minus 16 will be plus 16. Minus 4. So while considering 4, so we have to leave this and we have to multiply 14. 8 5s are 40. So minus 40. And plus 5 multiplied by minus 4 plus 5. Clear? Clear. So 3 multiplied by minus 7 plus 16 is 9 minus 4. 14 minus 40 is minus 26, which again plus 5 multiplied by 1. Clear? Clear. So if we again multiply this, sorry, so it will be 27 plus 104 plus 5. So which is equals, sorry, so it is equals 136. Clear? Clear. So now we are very clear with del equals 136. Okay? Okay. So what we are provided with three linear equations, and we are, according to the question, we have to solve it with Craner's rule. What's Craner's rule? X equals del 1 by del and y equals del 2 by del and z equals del 3 by del. Okay? Okay. To solve this, I have to make a matrix first, right? So I take a element A and we are going to make a matrix with elements only coefficients in the left hand side, right? Right. And we name another matrix X, which is equals XYZ, and with the elements of the right hand side we formed another matrix B, right? So initially we have to find del. So we take the determinant of a matrix A, right? We solved it and we will get del equals 136. I will give you 1 minute so that you can copy this and we will move to the next step. I hope you all copied this one, so I am going to rub this. Okay. Okay. So we are going to find del 1 first. Okay, I'm just going to write all the matrices above so that we can refer. A equals 3, 4, 5 and 2 minus 1, 8. 5 minus 2, 7. And x equals x, y, z. And b equals 18, 13, and 20. Clear? Clear. Now we already find del. Right? So what is del? Del equals 136. Now I am going to find del 1. Clear? As I said already, del is a determinant. What is del 1? So del 1 implies as it is also a determinant of a same matrix as del. Right? But we are going to replace column 1 with some more elements, right? So now we are going to replace the column 1 elements with matrix B, right? Right. So what we will get determinant of, so in place of this column we have to write 30 elements of B, 13, 18, 13 and 20. And other two columns remains the same, 4 minus 1 minus 2, 5, 8 and 7. Clear? Clear. So this is what we have to get del 1. See, here also we are going to solve with column row wise. So I am going to take 18. So this element. So it will becomes minus 7 plus 16 minus 4. While taking this, it will becomes 17. Sorry, 3 into 17. So that is 91 minus 160 and plus 5. Again 3 into 17. Okay, and minus 26 plus 20. Clear? Clear. So it will becomes 18 multiplied by 9 minus 4 multiplied by minus 69 plus 5 multiplied by minus 6. Okay. So what we will get? 18 into 9 is 162. Okay. Okay. 69 into 4 is plus. So here minus. So plus 276. And 6 5s are 30. Here it is minus. So minus 30. Which is equals. When we add two things and subtract, we will get 408. Clear? Clear. So this is what we find. What is del 1 is. So we can simply write del 1 equals 408. Clear? Clear. So I will give you 1 minute so that you can copy this and we will move to the next step. Okay. For my purpose, we are going to write del 1 equals 408. Here, right? Right. Okay. I hope you all copied this. Shall we move to the next step? Yes, sure. So what is the next step? Yes, super. So the next step is we are going to solve for del 2, right? Right. So we are going to solve for del 2. So what is del 1? We replace the element first column elements by elements of a B. So what is del 2? Simple. We are going to replace column 2 with elements of B. Shall we? Yes. So del symbolizes determinant. 3, 2, 5, 18, 13, 20, 5, 8 and 7. Clear? Clear. So shall we start to solve? We are going to solve this using column 1. Sorry, row 1. Okay? Okay. So which is equals 3 multiplied by 13 sevens are 91 minus 160. Clear? Clear. minus 18. Now I am doing this, so I will leave this one. So it will becomes 14 minus pressure 40 plus 5 multiplied by 40 minus 65. Clear? Clear. So what we will get? 3 multiplied by minus 69 minus 18 minus 26. Clear? And plus 5 and minus 25. Right? Right. So what is 3 multiplied by 69? What is 3 multiplied by 69? 207. Here plus, here minus. So minus. Minus into minus plus. What is 18 into 26? It is 468. And what is 25 multiplied by 5? 125. Here plus, here minus. So it will remains minus, right? Okay. What is this? The final answer. So the final answer is 136, right? Right. So we find del 2. So del 2 equals 136. How we find del 2? We replace the column 2 with the elements of B, right? Right. I will give you 1 minute so that you can copy this and we will move to the next step. Okay. Okay, I hope you all copied this one. Shall I up? Yes. Okay. Okay. So what we have to find now? Del 3. Super. We have to find del 3. So what is del 3? We have to take the elements of matrix A, but we have to replace column 3 with the elements of B. Shall we? Yes. So it is 3, 2, 5. 4 minus 1 minus 2. What is the elements from B? 18, 13 and 20. We are going to take the determinant, right? So 3. So while taking this, we have to leave this column and this column and this row. So we will have this alone. So we have to cross multiply. 1 minus 1 multiplied by 20 is minus 20. While doing this, we have to add a minus in already. So here it is minus 26, minus plus minus 26 is plus 26. Okay? Okay. Right? Right. While doing the second element of the row 1, we have to add a minus. So what we have here 4. While doing for 4, we have to leave this row and leave this column. What are they remaining? Here and here are remaining. So 2 into 20 is 40. While doing upwards, we have to put a minus. So 13 into 5 is 65. And plus, what is the last element? 18. While doing for 18, we have to leave these things. What we have remaining? These elements only. So while cross multiply this, 2 multiplied by minus 2 is minus 4. While doing upwards, we have to keep another minus. So here it is minus 1. Minus 1 into minus 1. 5. Clear? Okay. So 3 multiplied by 20 plus 6 is 6. Sorry, minus 20 plus 26, 6. Minus 4 plus 40 minus 65 is minus 25. Here. Okay. And here it is 18 minus 4 plus 1 is 1. So it will become 6 3s are 18. Minus into minus plus 4 into 100. Sorry, 4 into 2500 plus 18. So 18 plus 18, 36. 36 plus 100, 136. Now we find the value of del 3, which is 136. Yeah, okay. Del 3 equals 136. So now we find del 1, del 2, del 3. Okay? Okay. So I will give you 1 minute so that you can copy this and we will move to the final step. So I will give you 1 minute so that you can copy this and we will move to the next step. Okay. I hope you all written this, Sarah. Yes. Okay. Okay. So what we have now? We find del, which is equals 136, and del 1 equals 408, and del 2 equals 136, and del 3 equals 136. Clear? Clear. This is what we find till now. Okay? Okay. So what is Karna's rule? X equals del 1 by del and y equals del 2 by del and z equals del 3 by del. Clear? Clear. So now we know all the values del 1, del 2, del 3 and del. If we substitute these values in the equation, we will get x, y and z. Okay? So x equals del 1. What is del 1? 408. Right? Divided by what is del 136. Okay, we can cancel it to 136 or 6. 336 or 3 into 136 is 408. We can say x equals 3. Okay? Okay. So y, what is del 2? 136. What is del 136? So 1 1. So we will get y equals 1. And similarly z equals what is 1? Del 3. 136. What is del? Again 136. So they will get cancelled, which is equals 1. So what is the value of x? X equals 3. What is the value of y? Y equals 1. What is the value of z? Z equals 1. What we have to find? We have to find the value of x, y and z. So I will give you 1 more minute so you can copy this and we'll do a short recap. Okay? Okay. Okay. I hope you all like this. Okay. So shall we do a short recap? Yes. So first two sums we solved is those are simple sums. We have to do simple tricks and terms and determinants and we will find the given equation whether those two sums are in a format of show that, and we finally proved the given data, right? Right. So, but the third sum is different. We have to do commerce rule, right? Right. So the third sum is completely different. We are provided with three linear equations, right? Right. And we have to find the variables, right? So what we are provided with? We are provided with 3x plus 4y plus 5z equals 18 and 2x minus y plus 8z. 8 is it right? Yes. 8z equals 13 and 5x minus 2y plus 7z equals 20. See, in a previous sum, we are provided with three equations like this, and we are asked to solve these three linear equations using commerce rule. So, what is commerce rule? So, commerce rule is x equals del 1 by del and y equals del 2 by del and z equals del 3 by del. So this is commerce rule, right? Right. So in the question they are provided with three linear equation and I ask us to solve this using commerce rule. What is commerce rule? This is the commerce rule. Right. How we are going to do this? To take a determinant, we need a matrix, right? Right. Without a matrix, we can't take any determinant. So we split the given equation into a matrices. So we split this into three matrices. So what's the first matrix we take? What's the first matrix we take? We take is A. So A is the first matrix. So in A we take only the left hand side. Right? Right. So while writing the matrix A, C. While writing a matrix A, we are not taking a what is 3x, 4x. No, we are going to take like this. We simply take the coefficients of x, y, and z. Right? First equation, we will make it into a first row. So see, it is the first equation we have. So we simply make this as first row. For the second matrix, we simply make it as a second row. For third matrix, we make it as a third row. And we simply find the matrix A. Right? We already have another matrix, right? Right. See, why we are taking two matrices in the left hand side alone? We have elements and variables here, right? Right. So we simply take the coefficient of these variables as matrix A and these variables as matrix X, X, Y, Z. See? Okay. So, and we take another matrix, right? What is the matrix? Super matrix B. So, for these, we simply take the element at the right hand side. But as in the same order. What we have first? 18. And then we have 13. And then we have 20. Right? Right. Why we taken like this? We know that AX equals B. Right? Right. So, we take these three matrices and we are going started solving this sum. By how? By using taking del for these matrix and we find del 1 and del 2 and del 3 by replacing C1 and C2, C3 by elements of B and we find the value of X and Y and Z. Right? This is what Cramer's rule is, right? Right. So I hope you are clear with Cramer's rule and today's lessons and sums we solved. Do you have any questions? Means kindly put that in a chat box or unmute yourself and ask your questions, right? Right. Thank you.
Class over on.
Yes, sir. The class is
Thank
over.
you. Yeah, okay, thank you.
Okay, thank you. Guys, do you have any doubts? If yes means unmute yourself and ask the doubts. Or if you feel any shy or you can't unmute means kindly put the doubt in the chat box. Or else you can make an excuse and leave the class. Okay, no, I can't see any messages in the chat box, so I can assume myself everybody